to elimination. I think that's also the one that we are better at, is the elimination, okay? Some of these are going to be more challenging than others, but don't make them so hard because they're not as hard as they might sound, okay? All right, so when we're doing a word problem, the first thing that you need to establish is what your X and Y mean. What do they represent for the question? Because that's important. We have to know what X and Y represent. So if we read the question, 3 glazed donuts and 2 cinnamon rolls cost $4.75. 4 glazed donuts and 1 cinnamon roll cost $4.50. Find the cost of each. If you look at the question, what they're asking you to find, that's what X and Y typically represent. So if they're looking for the cost of a glazed donut and a cinnamon roll, then X and Y represent the cost of a glazed donut and a cinnamon roll. I will suggest strongly that you write that, okay, that you know what X and Y mean. And I'll make it shorter here. So I'm going to let X be the cost of that donut and Y be the cost of a cinnamon roll. Not how many, but it represents the cost. Look at the last question, and that's what X and Y are going to represent. Okay, from there, we go back and we read it again. Never do a word problem and read it once. It doesn't happen. You have to read a word problem 2, 3, 4 times sometimes, okay? So that is the case with all word problems. All right, so here's my first equation. The first sentence makes my first equation. 3 donuts, so 3 X's. And 2 cinnamon rolls, 2 Y's, is $4.75. 3 donuts, 2 cinnamon rolls is $4.75. My next equation makes, my next sentence makes my next equation. 4 donuts and 1 cinnamon roll cost $4.50. So 4 X's and 1 Y is 4.50. So now that's our setup. That's our new piece. That's our goal 8-4, setting up the word problems. So now we're going to solve it. So somebody tell me, I would use elimination, not substitution on this. What's the easiest way for for elimination? Easiest step to do to solve this using elimination? Ellen? Like
you do the top one times 4.
Even easier.
Times y by 2.
Okay, and I need one more thing with it.
Y, it'd be negative.
A negative 2. So we're going to take that bottom equation times a negative 2. So we're going to get y to drop out. We're going to take that bottom equation times negative 2. So solving it works just like the assessment you got back today. Figure out what you want to solve. Now, what Alan started saying about x's, Alan, that was fine. It's just more work. Okay? Okay, so I probably don't have room to go to the right. So the top one I'm leaving the same. And the bottom one is going to become negative 8x minus 2y equals negative 9. I need my calculator today. Okay, so let's add 3 and minus 8 gives me negative 5x. My y's are eliminated just as we planned. And 4.75 minus 9 is not that. Is a negative 4.25. Divide by negative 5. And x is 0.85. So x represents the cost of a donut. So I'll come back to that in a second because we got to find the cost of the cinnamon roll. So just like what we did previously in elimination, we're going to plug that back in to find our y. So let's go, I'm gonna go to the bottom. I'm gonna go right there. No, I'm not going there, I'm going for my x. I gotta plug it in for x, from right there. So I'm gonna have 4 times 0.85 plus 1y equals 450. So I'm going to take 0.85 times 4, and I get 3.4 plus 1y equals 450, and subtract 3.4, and I get y, or 1y, equals 1.10. And that represents the cost of a cinnamon roll. So make sure on a word problem that you label answers. So, donut is 85 cents, and the cinnamon roll is $1.10. That's what I'm looking for my final answer. Okay, some questions? Yes?
Did you have the dollar sign?
No. You can. Here enough. Now, a couple things. On a question like this, if you come out with a negative, you know you're wrong. Because you can't have a negative cost. It's free then, basically. Okay? So know that things like that are a big ding, ding, ding that you know something's wrong. Okay? Okay, question 2. Each question I'm going to do is slightly different in terms of what the kind of stuff they're looking for. Okay? All right, Kate's piggy bank has $3.65 in it, all nickels and quarters. There are 21 coins in the bank. How many nickels and how many quarters are there? So again, when we're looking at what our variables represent, we're looking at the final question. How many? A quantity, okay? How many? So how many means x and y represent the number of them. How many? So the number of nickels and the number of quarters. So x, and it doesn't matter which one's which. But again, look at the final sentence. Look what they're asking for. That's what your x and y are going to represent. Okay, so this one's not as straightforward as the first one was. Okay? You're going to have 2 equations for the system, as always, 2 equations, x and y. One of them is a very simple equation, meaning there's not a lot to it. It looks simple. Okay? And that deals with the quantity of coins. X and Y. You have 21 coins altogether. If X and Y represent the number of coins, then together X and Y is 21. So there's my one equation. The number of coins, the quantity, how many you have. The other equation deals with the value of the coins you have. You have $3.65 worth of coins. It doesn't make sense to say x plus y is $3.65 though, okay? Because that would be the number of nickels, the number of dimes equals $3.65. No. So the second equation, you have to put some value on those x's and y's. So a nickel is worth 5 cents. So 5 cents for every nickel I have. 0.05 times x. Plus 25 cents for every quarter I have. 25. 0.25 times y equals how much money Kate has in her piggy bank. So the second equation, definitely more involved, deals with the value of the coins that you have. Now, I will just say, I think that looks messy in terms of decimals. I don't write this equation like this when I do these, okay? But I want you to make sure you see it written with the actual value of a coin, okay? I would take the decimals out and make everything in cents instead of dollars. So right now it's written 0.05 because that's the value of a nickel in terms of a dollar. A quarter, 0.25 is the value in terms of a dollar. 3.65 is how much you have in terms of dollars. So if I take all the decimals out, it becomes this. 5x plus 25y equals 365. So 5 cents, 25 cents, 365 cents. Really all you're doing is multiplying it all by 10 because it moves the by 100 because it moves the decimal 2 places, 2 places, 2 places. So I'm going to give you the choice on a question like this, that you can write this if you want, or you can just write it like this with no decimals to begin with, or write it like this, then write it like this, okay? I don't even write this one to begin with. So I don't even need to see the decimal equation. I'm going to let you choose which way you want to do it.
Well, then after you find the answer, do you change it back to dollars?
No, you won't have to. You won't have to. Because we're looking for how many, so it's not going to be, we're not even going to get decimals. If we get decimals, we're wrong because we can't have 1.2 dimes or nickels. Okay. All right, so I'm gonna just mark out this equation. I'm gonna do it kind of weirdly. I'm gonna just scratch that one out, but you can still see it. Okay. So I'm not using that one. So this is my system. X plus y equals 21. 5x plus 5y is 365. Okay, so we're trying to find out how many nickels and quarters there are. Again, I like elimination better for this. So somebody tell me, what am I going to do to get x or y to drop out? I don't care which one you do. It doesn't matter to me. Thomas.
Multiply the top by -5.
All right, we're going to get x then. He's going to take the top equation by -5. So I'm going to end up with negative 5x minus 5y equals 105. 21 times 5. Negative 105, sorry. The most common mistake, although the assessments were fantastic, the most common mistake made on the assessment you got back today was not multiplying that number. Okay, so make sure you take it all the way across. Okay, so now I can add down and I get those cancel. 20y equals 160. Y equals 8. Divide by 20. Now, let's look at where we got to plug that back in. We got to go back to one of those original equations. This is way easier. Don't go here. I mean, if you really want to, you could, but this is way easier. So let's plug that in there. Right there. Oh, sorry, that's my phone. You can tell how often I use my phone. I don't usually even have it on. Okay, so x plus 8 is 21. Subtract 8. And x is 13. Yes, did I make a mistake?
Yeah, it's 260, not 160.
Oh, it is 260. Thank you. Dang! So that's 13. And funny, that's kind of funny though, because then you plug 13 in and you get 8. Thank you, thank you, thank you.